Hi there, my name is Miss Midha, and today we're going to focus on the following question. How do you estimate a population mean? So we are actually going to be conducting an experiment using, a standard number cube in a little bit. But before we do that, we want to just sort of think about what the distribution of values from rolling that cube a certain number of times. We want to think about what the distribution of values are going to look like. So let's go ahead and get started. All right, so as it says on the next slide, you're going to be rolling a number cube 35 times. Now, if you don't have a number cube at home, a six-sided die, don't worry about it. I'm going to also show you an applet that you can use. It's from Geogebra. I'll show you an applet you can use to simulate a rolling of a die. Okay, before we do that, though, I'm going to ask you to do the two following things. Draw a dot plot that shows the distribution of values you might expect for the rolls, and explain your reasoning, right? Think about why you did what you did. And then think about the following question. If you rolled a number cube 1 million times and found the mean of all the values, what do you expect for the mean? So pause the video, take as long as you need to create this dot plot, remembering that your dot plot is showing distribution of values that you might expect for the rolls, right? What do you anticipate the distribution of values to be? And then once you've drawn the dot plot, think about what the mean would be if you roll the number cube 1 million times. Once you think you have these down, unpause the video and we will review. Okay, now your dot plot might look slightly different, but this is pretty much a general dot plot that you should have, or something very, very similar. Now, why do I say that? Well, there was no preference for one number over the other, right? In a six-sided die, when you're rolling a six-sided die, there is absolutely no preference for one number over the other, right? So what does that mean? Well, that means that the distribution, we expect that distribution to be fairly uniform, right? Pretty uniform right here. Now, of course, it may not be as nice as this because some randomness is always involved, but it's going to be this general shape. Okay, now, if we roll that number cube 1 million times, what do you think the mean would be? So if I think about this, again, the distribution is fairly uniform. That tells me that the distribution is approximately symmetric, right? And so if I think about, well, each number should show up about the same number of times, I really want to think about what is the middle of my distribution here, right? What is the middle of my distribution? Well, I can see the middle of the distribution right here is 3.5. So if I were to roll that number cube 1 million times, what do I expect for the mean? 3.5. Okay, now that we sort of thought about this before actually conducting the experiment, now we're going to go ahead and conduct the experiment. So let's go ahead and get started. So here we go. Okay, now if you have a number cube at home, again, a six-sided die, you're going to roll this number cube 35 times. If you don't have a six-sided die, a standard number cube at home, or wherever you're watching this video, you can go to this website. Okay, this is Geogebra. We've used Geogebra in previous videos if you watched any of the other videos, so hopefully you're familiar with this. I'll show you what the applet looks like in just a moment. But essentially, you're going to either roll a physical number cube or you're going to use that applet on Geogebra, and you're going to simulate rolling a die 35 times. Now, when you're doing this, you want to record the values as you do so. So you're going to record all 35 rolls. For every 5 values, so rolls 1 to 5, 6 to 10, so on and so forth, you want to find the mean and record it into a table. Again, rolls 1 to 5, once you found the 5 values for rolls 1 to 5, you find the mean for those 5 rolls, and then you write it in a table. After you have recorded everything in a table, you want to create a dot plot of the means. Now, before I remind you to pause the video, I do want to show you what this website looks like on Geogebra. So this is it right here. When you go to that website, you're going to be in the probability and intro to statistics unit. And so if you just click on roll die simulation, this is the applet that you want to use. And all you have to do here is literally just press roll, 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 and it'll show you a new number or maybe the same number sometimes for as many times as you simulate this roll die. Again, you are going to do it 35 times. Okay, so one more time, I'm going to put the other screen back up just to remind you on what you're doing. Rolling your die 35 times, recording the values. For every 5 values, find the mean recorded in the table, and then create a dot plot. Once you have everything done, on pause, and we'll review. Okay, now your means may be different than mine, right? Because this is our own experiment. I went ahead and used the GeoGebra applet, and for every 5 values, I recorded the mean. And these are the means that I had. Now, hopefully you have created a dot plot using your means. I'm going to actually show you how to create this dot plot on Desmos. Now, if you're familiar with how to create a histogram on Desmos, it is very, very similar. So again, if you have no idea what I'm talking about, there is a video from several lessons ago that shows you how to create a histogram on Dotplot, a histogram on Desmos. It's very similar to what we're going to do. So you are going to go to desmos.com. That's the first thing. And in that first line, you want to put in your means in a set. And so you have to name your set. So I'm going to name it x sub 1, and I'm literally going to write the values that I had in my table. So I had 3.8, I had 3.4, I had 2.8, I had 3.2, 4.4, 3.6, and 4.4. All right, 7 elements, checks off. Now I have to create a dot plot. So in line 2, I'm going to click on this keypad on the bottom left corner of my screen. I'm going to go to that button that says functions, and I'm going to click on this right here, DIST, distribution. Now, lots of potential items that you can click on. Since we're making a dot plot, I am going to click on dot plot. All I have to write here is the name of my set, and that is x sub 1. Now, notice what just happened. All of my values were created into a dot plot. And I'm actually going to go ahead and just sort of zoom in a little bit just so we can see this a little bit nicer. We know, of course, that, let me try that again. We know that this is going to be in the first quadrant, right? We're looking at a dot plot here so we can see it a little bit cleaner. And it looks right? We have a value at 2.8, 3.2, 3.4, 3.6, 3.8. And we are good to go. So this is how you create a dot plot. And just a reminder on what we did. What we did was we did look at an experiment. We thought about an experiment before we actually completed the experiment, and we anticipated the distribution of values from that experiment. What was going to happen, right? Like thinking about what the dot plot would look like. And then we actually conducted the experiment. And we created a dot plot using Desmos.